Hello everyone and welcome. I'm Wongil Gising. Today we are diving into a complete one-shot masterclass on quadratic polynomials, meticulously designed for CBSE Grade 10 basic and standard students. To ensure complete preparation, we will solve every critical question type handpicked from NCERT, your past board papers, and trusted publishers. Because this is an exhaustive deep dive session, it took several days to put together. So I highly recommend watching it in sessions, taking strategic gaps to keep your learning effective. Feel free to fast forward if you're familiar with a specific concept or solution. So grab your notebook, set your own pace, and let's master this chapter together. Let us start this chapter with the term polynomials. What does it actually mean? Okay, so these are all algebraic expressions. We will learn which one of them is a polynomial and which of them will remain as algebraic expressions. All of them are algebraic expressions, but some of them are not polynomials. Now, for an algebraic expression to become a polynomial, the rule is simple. The power of the variable must be a whole number. So a whole number starts from 0, 1, 2, 3. So power of a polynomial is that in an algebraic expression you see variables, its power must be natural number plus 0, which we call set of whole numbers. Okay, so if we look at the first one, the variables are x and y and their powers are 2 and both are 2. So these are 2 is a whole number, therefore this is a polynomial in two variables. The variables are x and y. What about this? The power of x is here 1, it's 3. So this is also a polynomial in one variable because its power is a whole number. So this is a polynomial in one variable. What is the degree of this polynomial? Well, degree means the highest power of a polynomial. So the highest power is 3. Therefore, the degree of this polynomial is 3. The degree of this polynomial is 2. Okay, now look at this. Is this a polynomial or is it just an algebraic expression? So this one can be written as, so if you remove the root, it is 4x to the power half plus 3. Since the power is a fraction, this is not a polynomial. This one, the power of x is 1. So this is also a polynomial and we call this a linear polynomial. A linear polynomial in one variable, right? Linear polynomial, its highest degree is always 1. What about this? Is this a polynomial? So this can be written as x square plus, if you bring this x in the numerator, now you can see that one of the power is a negative number. So power of the variable should not be negative or fraction. Okay, it must be only whole numbers. So that's why this is also not a polynomial. So this remains only an algebraic expression. So an algebraic expression is no, made up of variables like x, y, z, um, and we have coefficients, constants connected by plus sign and minus sign. So to qualify as a polynomial from that algebraic expression, the power of each variable must be a whole number. So that is the rule. So this one, power of x, if it is nobody means it's 1, not 0. Okay. So this is also a polynomial, and this polynomial is called quadratic polynomial. Quadratic polynomial in one variable. What about this? This this is also a polynomial, because you may see only one term. A polynomial where you see only one term, it is called a monomial. A specific name of a polynomial containing only one term is called a monomial. It's a polynomial because the degree of the variable is a whole number. Number seven, just like looking at it, you cannot, uh, you know, mm, guess the answer correctly. You need to simplify this expression. So after simplification, we can confirm whether it's a polynomial or not. Look here. So this root p can be written as p to the power half. So this p's power is 3 by 2. This is half. So using the law of indices, when same bases divide, the powers will subtract. So it's going to be p4 plus, this is 3 by 2 means 1.5. So 1.5 minus half, it is 1. Hence, this is also a polynomial whose degree is 4. Means the highest power is 4. So I hope you understood what is a polynomial, what is an algebraic expression. Okay. Let me show you one more example. When we are talking about polynomials, even constants like 0, 1, root 3, minus 2, these are all constants. Let's say fractions. These are all constants, isn't it? They are also polynomials when we are talking about polynomial. Means like, is one a polynomial? Someone asks. Then you can say, yes, it is a constant polynomial. Because how are you, defining this one as a polynomial is, you can write x right beside 1 and give a power 0. Because 0 is a whole number. So this one has a variable whose power is 0. So that's why this is a polynomial, or we call this kind of polynomial a constant polynomial. While 0 is called 0 polynomial. These are all constant polynomials. So 5 by 2 can also be written as, right? So yeah, if you are only talking about numbers, you can say number is a constant. But when you are when the topic or the issue is about polynomials, even numbers are considered polynomials. Uh, we call them constant polynomials, and the degree of constant polynomial is 0. That is very important. The degree of a constant polynomial is 0. And also one thing, usually, let's say this is a polynomial. Okay. So what we will see here or in your book, that a polynomial is written as px or gx or f of x. So these are just naming the polynomials. Although this is the polynomial, so we are naming this polynomial by px, gx, fx. So if I write px, so the reason I'm writing x inside the bracket is it is made up of x. That's why we are saying px. We could have said fx or gx. Although this thing, becomes different when we study um, px, fx, gx in grade 11. But now think that these are all, this thing is only, we are giving names to polynomials. So if you see something like this, x y squared plus 3x 3y, then this polynomial is made up of y. So we'll say it is, let's say, f of y. Okay, x plus 1. This is a polynomial in one variable, and it is a linear polynomial. So we can name this polynomial by gx. So naming a polynomial by this way, uh, you know, when is it helpful? It's helpful when, when we are finding the value of a polynomial. So value of a polynomial means, what is the value of this polynomial when x is 1. Okay, so when x is 1, the value of this polynomial is, first you are naming this polynomial, let gx equals to this. So when x equals to 1, what will happen to this polynomial? So we put, wherever it's x, we put 1 and substitute the value of x by 1. So value of the polynomial when x is 1, it is 2. Similarly, value of the polynomial when, we can say here, when x is 2. So we'll find g of 2. So g of 2 is 3, 2 square plus 2 into 2 plus 1. You simplify and you get the answer. So it is 2 square is 4, 3 4s are 12, 4 plus 1, 16, 17. So value of this quadratic polynomial when x is 2 is 17. Okay, so let's move on. In your syllabus from the chapter polynomials, you have only two kinds. Earlier you had three, now they have excluded one, and so you have two types of polynomials. One is a linear polynomial. This is a linear polynomial. Example, let's say 2x plus 3. This is a general form of a linear polynomial, right? Linear polynomial in one variable. In one variable, in this case, the variable is x. So an example of this kind is ax plus b, where you can see a is 2 and b is 3. Or 1. What about this? So this is also a linear polynomial. If you compare this with the general form, your a is minus 1 and b is 1, right? So it's minus x means actually minus 1 into x plus 1. Similarly, I can give you one more example, y minus 3. So what about this? If you compare this with the general form, this is also a linear polynomial in one variable, and the variable is y here. Okay. So here a is 1 and b is minus 3. So whenever you see a linear polynomial, I hope you can um, pick out, pick, a and b properly. Suppose you see only this 2x. Is this a polynomial? Yes, this is a polynomial. It is a linear polynomial because the degree of x is 1. Linear polynomial means linear polynomial in one variable or two variable. The word linear means the degree of the variable is 1. So here the degree of variable is 1. So but the constant part is not here, so you can write 0. So a is 2 and b is 0. Okay. So in your syllabus you have linear polynomial in one variable. So only you see only x or y or z, but you won't see two variables whose power is 1 in a given expression. So this is the kind of polynomial that you will see. Next kind of polynomial is quadratic polynomial, a very important one. Ax square plus bx plus c. This is called a quadratic polynomial uh, in one variable. Since it is made up of only x, and a, b and c are constants, means numbers, where a and b are coefficients of x square and x respectively. Like coefficient means a number standing in front of x square and x. Okay, an example of a quadratic polynomial you have seen many times. This kind of polynomial, let's say, so this is a quadratic polynomial. You see the degree is whole number, the powers are whole numbers. The degree of a quadratic polynomial is 2. Degree means the highest power is 2. So if you compare this with the general form, a is 3, b is, you have to consider the minus sign also, b is minus 2 and c is 1. Okay. Next example of a quadratic polynomial. Let's say is this a quadratic polynomial? Yes, it is a quadratic polynomial. And if you compare this equation with the general form, this can be written as so you don't see the x part here, so you'll have to put like this. You'll have to write like this and say that a coefficient of x square is minus 1, b coefficient of x is 0, and c is 3. So since here in this polynomial the x part is not there, means x actually exists in the polynomial, but it's the coefficient which is 0. It's making your x part disappear. So this is how you should uh, you know derive a, b and c from a given quadratic polynomial. Let us give one more. Okay. Okay. Is this a quadratic polynomial? Yes. The degree of the polynomial is 2, means it's a quadratic polynomial. So although you don't see the constant part here, compared to this, comparing with the general form. So we'll consider it as 0. So here A is 3, B is -2, and C is 0. So I hope you understood what is a quadratic polynomial in one variable and a linear polynomial in one variable. Now we will be solving questions from these two polynomials, especially most of the question, almost 80% of the question will be from quadratic polynomial. And I also would like to mention that uh, the next chapter, chapter number 4, quadratic equation and quadratic polynomials are almost similar. So every question can be mm, thought of as a question coming from quadratic polynomial can be thought to be a question from quadratic equation, or if a question comes from quadratic equation can be thought it's from this chapter. So even the questions are similar. So for example, what is the I'm going to explain both of them simultaneously because the questions are the same. The only difference you'll see is that uh, in quadratic equation you'll get word problems. um, so from that word problem you'll have to form an equation and solve them, right? Otherwise there are so many other things besides word problems which are exactly the same from polynomials, quadratic polynomials and quadratic equations. So when does a quadratic polynomial become an equation? The moment you give this expression an equal to sign. It's not necessary that you'll have to give 0, but let's give 0. If you give the symbol equal, this becomes an equation. Similarly, this is a linear polynomial, but if you give the symbol equal, you'll have to write some number. Let's give it 0. This becomes an equation. So an equation has an equal to sign and a left hand side and a right hand side. So this is the difference between quadratic polynomial and quadratic equation, linear polynomial and linear equation. So these are not linear. This is not a linear polynomial now. It's a linear equation. This is a quadratic equation. All right. Now I have some questions to solve here from the chapter polynomials. Let's begin. All right. Next we have find the zeros of the following quadratic polynomials. So these are the three quadratic polynomials given. We'll have to find the zeros of the following quadratic polynomials. So what does zeros of the quadratic polynomial or zeros of the polynomial mean? Consider this example, the first one. So this is the given polynomial, quadratic polynomial in one variable, that is x, right? The power of x is a whole number. So this is a polynomial. Now 0 of this polynomial means, in particular, those values of x. You can give any value to x here, okay, and check what happens. But 0 of this polynomial means the values of x which will make this polynomial 0. Like for example, if you name this polynomial px, since it is made up of x, so if we give x as 1, if we take x as 1, then what will be the value of this polynomial? Let's see. It's going to be 6, 1 square minus 3 minus 7 into 1. 6 minus 3 minus 7. So this is minus 10 minus 4. So when x is 1, the value of the polynomial is minus 4. So likewise, there will be at most two values of x. means maximum two values of x for this polynomial. Those two values of x, when you substitute, it will become 0 after simplifying. Wherever you see x, you substitute the values. Like I tried for 1, it is not coming 0. So minus 4 is just the value of the polynomial when x is 1. So similarly, I can try minus 1, 0, minus 2, half, any real number that you give to x. So which value of x, the polynomial, for which value of x, when you substitute, the polynomial is becoming 0. That value of x, that value of x is called 0 of the polynomial. So there is a method to find the zeros of the polynomial, which we will apply here and find the zeros of these polynomials. How do you find the zero of this polynomial? So my suggestion is just equate this to 0. So after equating to 0, um, I'm doing it here. So now this looks like ax squared plus bx plus c equals to 0. So this is a quadratic equation, right? The moment you equate this to 0, it will become a quadratic equation. Now we will factorize this quadratic equation. Factorize means you'll show this as a product of something into something. How do you factorize? You multiply the coefficient of x square with the constant term. So that is 6 3s are 18. Now, once you multiply the coefficient of x square with the constant term, you further factorize 18 into all possible factorizations. So 18 can be written as 6 into 3 is 18, 9 into 2 is 18, or let's say 18 into 1 is 18, and there are prime factorizations of 18 also, right? But here you can try these three. Now next, what? Use the one out of these three factorizations, use the one from which, product of the numbers, product of the digits is 18, and but if you add or subtract them, you must get 7. So it is this. So 9 into 2 is 18, 9 minus 2 is 7. So here we'll write 6x squared, but minus sign is also there. So that the bigger number will take this sign, 9x. The smaller number, you'll have to adjust it yourself. So smaller number has to be plus 2x. Why plus 2x? Because only keeping it positive, the difference between them will become minus 7x. Minus 9x plus 2x is minus 7x. If you had kept this as also negative, then the answer would have been minus 9x minus 2x is minus 11x. That is wrong. Okay. So after simplifying, you must get this number only. So next is a very simple step. Okay, now you have successfully broken the middle term, right? Now you find common from the first two term and common from the second two term. So common from first two term is 3x. 3x into 2x is 6x square, and 3x into minus 3 is 9x, minus 9x. This sign will come here automatically. If it is plus, plus, if it is minus, minus. Now what is common between two? Nobody is common means 1. So write whatever is left as it is. So equals to 0. Next, 3x plus 1, and the numbers inside the bracket you keep in one place, and the rest you keep it in another bracket. So now this is a factorization of the quadratic polynomial. Means You showed that this polynomial or this equation is something into something equals 0. So when you multiply two things, let's say this is A and this is B. When you multiply two things and it's becoming 0 means either A is 0 or B is 0. This is the concept used here. So if A is 0, that's why the answer is 0, right? If this is 0, it can be either this is 0 or this is 0. So if A is 0, that means 3x plus 1 equals to 0 or 2x minus 3 equals to 0. Next, x equals to, you solve this equation, this becomes a linear equation in one variable. So solving this, you have x equals to minus 1. So x equals to 3x equals to minus 1. So x equals to minus 1 by 3. Or this one, I'm doing it directly. You have 2x equals to 3. Okay, let's go slow. So you got two values. One is x equals to minus 1 by 3. Another is x equals to 3 by 2. So these are the zeros of this quadratic polynomial. Okay. So in order to find the zeros, we had to equate it to 0 and do this thing. Okay. Once we equate this to 0, it becomes a quadratic equation. The same thing that we will do in quadratic equation chapter. There, the zeros of the equation means those values of x that will make the equation 0 are called roots of the quadratic equation. So these values x equals to minus 1 by 3 and x equals to 3 by 2 are called roots of the equation. But in the case of a polynomial, we call it zeros of the polynomial. So I hope you understood and you copied. So these are the zeros of the polynomial. Like I said, that if you substitute the value of x as minus 1 by 3 or 3 by 2 at a time, not this is minus 1 by, this x is minus 1 by 3 and this is 3 by 2, they won't become 0. If it is 1 by minus 1 by 3, here also you will have to put minus 1 by 3. Then it will come 0. Or if you put x equals to 3 by 2, 3 by 2, it will come 0. So that's why they are called zeros of the polynomial. Next, if you want to find the zeros of this polynomial, this is also a quadratic polynomial. Here, if you compare with this, the constant term is not here, not there. So you cannot find the zeros by similar method like middle term break. What you'll have to do is, even here you'll have to equate it to 0. So you can take common. Right? Common between these two is 4u. Now, comparing this into this equals to 0 means what? Either 4u equals to 0 or u plus 2 equals to 0. So 4 cannot be 0, so u must be 0. Or you send this 4 to the other side, 0 divided by 4 is also 0, right? So either u is 0 or u is minus 2. So u equals to 0 and minus 2 are the zeros of this polynomial. Okay. And it is true also. What? The previous one also. If you put u equals to 0, so 4 into 0 square is 0. 0 plus 8 into 0, 0. So altogether it will become 0. And if you put u equals to minus 2, still it will become 0. You want to see 4 into minus 2 square plus 8 into minus 2. So this is minus 2 square is 4. 4 4 is 16. Minus 8 into 2 is 16. So 16 minus 16, it is 0. So that's how it works. Okay. So, so for this kind of polynomial, and they have given also in CBSE board exam once or twice, they have asked you to find the zeros of this type, and it's easy, but students got confused and they could not solve it. So this is how it's done. So these are the zeros of this polynomial. Now, why equating it to 0 and solving this? The logic behind is you are considering for some value of u, or the previous one, this one, for some values of x, it is becoming 0 ultimately, right? So we are considering, let this become 0. Let this become 0. Now you are solving at what value of u it is becoming 0. So the final one, t square minus 15. Similarly, equate it to 0. So you are finding 0 means at what value of t everything is becoming 0. So we are considering, let this be 0 for some t. Okay, for some value of t, that this whole thing is becoming 0. So that value, now in order to get that value, it becomes an equation and it's easy to solve. Now t equals to this 15, you send to the other side, it's this, and once you square, you send it to the other side, or there is, mathematically it's not actually sending. What you are doing is, you are doing you are putting square root on both sides. So, or in simple language, let's take it that you are sending this 2 to the other side, then it will become root, right? So it becomes root, so t equals to root 15. So you may think that, okay, we got only one value for here, we should be getting two values for t, but we got only one value, that is root 15. That's correct, but what you should know is, since it's a quadratic polynomial, you must have two values. So this is plus and minus, this, yeah, you have to give. So one value of t is root 15, that means positive root 15. Another value of t is minus root 15. So both are zeros of this polynomial. If you give t equals to root 15 and square them and subtract, it will get 0. If you give t equals to minus root 15 and square and subtract with 15, it's 0. So both are zeros. So that's how zeros are defined. So, well, it's not necessary that the two zeros that you will get here are distinct, means different. In this case, we got one, but we said one is plus and one is minus. Okay, that's okay. But there are cases where we'll get two zeros, but both are equal. So sometimes there are two zeros, like the first one, two zeros both were different. Here, two zeros both were different, 0 and minus 2, I think. And here, two zeros both are different. But there are cases where we'll get two zeros and both are equal. That we will learn in the nature of zeros or nature of roots of quadratic polynomial slash quadratic equations. So that is also in the syllabus. Alright, so this was about finding zeros of a quadratic polynomial. What about, how will you find the zeros of this linear polynomial 3x minus 6? So here also, what is the zero of this polynomial? The question. How many zeros will you get, by the way? The degree is 1, means you'll have only one zero. Means you'll only have one value of x which will make this polynomial 0. So in order to find that, we equate it to 0. Okay. and it becomes a linear equation now, not a linear polynomial. Now solve this equation. 3x equals to 6, x equals to 6 by 3. So x equals to 2 is the 0 of this linear polynomial. And it is true. Put it here. 3 into 2 minus 6. 3 2s are 6. 6 minus 6 is 0. As simple as this. So now we are about to start a subtopic from this chapter, relationship between the zeros and coefficient of a quadratic polynomial. So let this be a quadratic polynomial. If x equals to ax squared plus bx plus c, a general form of a quadratic polynomial, and consider alpha and beta are the zeros of the polynomial, means alpha and beta are those values of x. If you put it here, it makes it 0. So the relation between the zeros and the coefficients a, b and c are given by sum of zeros is minus b by a. What are the zeros? Alpha plus beta equals to minus b by a, and product of zeros c by a, that is, if you multiply the two zeros, it is c by a. So these two are key formulae for this chapter, um, that sum of zeros is minus b by a. This is your b and this is your a, and product of zeros is c by a. So I would like to do and solve a simple question and show you how it works. Let's say the question is this. Your polynomial is so this is a quadratic polynomial. Px equals to 3x square minus x minus 4. What are the zeros of this polynomial? So in order to find the zero, we equate the polynomial to 0. Now, uh, now we factorize the polynomial. So 3 times 4 is 12. So this is so I hope you are getting what I'm doing here. So why am I factorizing the polynomial? Here is in order to factorize, the way of getting the 0 is by breaking the middle term. So how am I breaking the middle term? You first multiply the coefficient of x square with the constant term, that is 3 4s are 12. You factorize 12. After factorization, I see that 4 into 3 is 12 and 4 minus 3 is this. So this I'm taking common from the first term. I see that it's only x, 3x minus 4, and nobody's common, means 3x minus 4 equals to 0. So, okay, I don't have a space here. So I have therefore my zeros are x equals to, if I equate this to 0, x equals to minus 1, and if I equate this to 0, x equals to 4 by 3. I'm writing it directly. Okay, so these are the zeros. Let's say one is alpha, another one is beta. So let's verify. The question can be verify its relationship between zeros and coefficient of the quadratic polynomial. So first we find the zeros. So I found the zeros are -1 and 4/3. So you equate this to 0, an equation will be formed. So x equals to -1. Next you equate individually, okay, this to 0 and solve, you'll get x equals to 4/3. So consider this is alpha and this is beta. Now sum of zeros, alpha plus beta must be minus b by a, isn't it? That's the verification. So if your left hand side equals to right hand side, then we are going in the right direction. So let's add -1 plus 4/3. And on my right it is minus b. What is b from here? Okay, looking at this, your b is -1, your a is 3, and c is -4. Okay, so minus is already there, b is -1, and a is 3. So it is 1/3. Minus minus plus, so 1/3. So on my right it is 1/3. On my left also it should come 1/3. Now you can take the LCM and see this is also going to be 1/3 only, because here if you take LCM 3 and this is going to be -3 plus 4, so this is 1/3. Hence RHS equals to LHS equals to RHS, therefore this is verified. Now similarly, let's go for product of the roots. So alpha into beta equals to c by a. Alpha beta -1 into 4/3 must be, what is c? It's -4 and a is 3. So if you multiply, it is -4/3 equals to -4/3. You'll write verified. Therefore we see that this is how zeros and the coefficients of a quadratic equation are related. Okay, and questions are not going to be as simple as this one, but they can give similar to this. But I have several important questions that we have seen in the previous years, or having a possibility of coming next year. So let's try those questions. Okay, so we have this question. If the sum of the zeros of the quadratic polynomial, this, is 3, then the value of k is what? Okay, so compare this quadratic equation, polynomial with the general form. Your a is 3, b is -k, and c is 6. Remember, b is a number in front of x, including the sign. Okay, a is a number in front of x square, which we call coefficient of x square. Minus k is coefficient of x, and this is the constant term. Now they're saying that if you sum of the zeros, let's say, okay, you don't have to say anything here. Sum of zeros, what is the formula? Sum of zeros is minus b by a, and they have said that sum of zeros is 3, and minus, what is b? Minus k, and A is 3. So 3 comes here, 3 into 3 is 9, minus into minus is plus, so K's value is 9. So I hope you understood. Let's move on to another question. So we have another question. If one root of the equation this is the reciprocal of the other, then find K. Now instead of, in place of polynomial, they have said equation. Not a problem, because even this is quadratic. Here it's a quadratic equation because we see an equal to sign. So if there was no equal to and nothing on the right hand side, this would have been a quadratic polynomial. The same thing would have been applied. So if instead of equation they write it polynomial, you don't see this part. If it is an equation, there will be an equal to and a number on the right. They have put 0 here. Okay, so this is going to be really helpful as well as important for both the chapters, for quadratic equation and quadratic polynomial. So they've said one root of the equation, root or zeros means the same, okay, where the value of x, if you put here, it's going to make it 0, isn't it? So those are called zeros in the case of quadratic polynomial. And if it is a quadratic equation, those values of x which make it 0 are called roots of the equation. So what we'll do is, let one root be alpha. Let one root be alpha. Then the other is reciprocal. Okay. So reciprocal means 1 by alpha, isn't it? So if 1 is 2, the reciprocal of 2 is 1 by 2. If 1 is 3, reciprocal of 3 is 1 by 3, like that. So this is the case. Now comparing this equation with the general form, your A is k minus 1, B is minus 10, and C is 3. You'll have to find this k. Obviously, you'll be using the relationship between roots and coefficient, zeros and coefficient. The same thing that we did. Sum of zeros is minus b by a, and product of zeros is c by a. So, which one is going to be helpful here is product of zeros, not sum of zeros. Now look here, product of zeros is c by a. What are the zeros? One is alpha, another is 1 by alpha. They haven't said what are the zeros. They have just said that the root are such that the other, if one is the root, the other is just the reciprocal of that. Okay. So one is alpha, another is 1 by alpha. What is C? C is 3 and A is k minus 1. So alpha and alpha will get cancelled. You have only 1, bring it here. So k minus 1 equals to 3. You cross multiply it. Okay. So k is equals to, send 1 to the other side, it is k is equals to 4. So this is how simply, this kind of question is solved. If one root of the equation or the polynomial is reciprocal of the other, then we will use product of zeros, this relation. Because doing so, what happens is they get cancelled and we are left only with 1, and the unknown in this equation is only 1, means the unknown thing is only k. So if there is only one unknown in an equation, it's easy to solve, right? not easy to solve, it's solvable. So this becomes a linear equation in one variable, that is k, so you get the answer. So what if you had used sum of zeros? Then sum of zeros would have been uh, a problem like this. It goes like this. If sum of zeros were used, then you have to do alpha plus 1 by alpha equals to minus b by a. So b is this, minus minus will be, and a is k minus 1. If you use sum of zeros relation, it will become like this. So here you will take LCM. After taking LCM, it will be alpha square plus 1 upon alpha equals to this. So if you use this one, this relation, then what happens is you'll have two unknowns in an equation. One is alpha, which you don't know, another is k. So that is why this is not solvable. Hence, the only way and the fastest way is to solve by this method. Let's try another one. By the way, this is your homework. The similar question here also, your 1 0 is reciprocal of the other. So the question is 5x square plus 13x plus k equals to 0. So you'll have to find k, and when you find the, your k must be equal to 5. So solve it. And now we'll move on to another question. All right, we have this interesting question, an important one. If 1 0 of the quadratic polynomial, this is a quadratic polynomial, is negative of the other, then find the zeros of this, this quadratic polynomial. So if you want to find the zeros of this quadratic polynomial, you'll have to know the values of a, values of k. Okay. Only after knowing the values of k, you'll be able to find the zeros of this quadratic polynomial. So how will you first find the value of k here? That k you'll substitute here, and you'll get a new polynomial, and we'll find the zeros of this polynomial. So the answer goes like this. Let's write the given polynomial fx. Okay. So fx can be written as, take x common. So it is right. So inside minus means minus, minus plus. Okay. So now comparing this with the general equation, your a is 4, b is minus of 8k minus 8, and c is minus 9. They are saying that 1 0 of this quadratic polynomial is negative of the other. So let us consider, let alpha be 1 0. Then the other 0, and the other 0 is what? Tell me. If we consider 1 0 means one value of x to be alpha, then the other value of x is minus alpha. Okay, this is the key thing. This negative of the other means. So here also we are going to use the relation between zeros and the coefficients, but which one would be uh, appropriate is this. Sum of zeros. Sum of zeros is minus b by a. So it is, our zeros are alpha plus another 0 is minus of minus alpha. B is this. Okay. So b is, I'm writing it minus So this becomes 0. When you add them, it is 0. You bring 4 on this side, 4 into 0, it's 0. So it's going to be 0 equals to minus and minus is plus 8k minus 8. So if you solve this, you'll get 1. So 8 equals to 8k. Bring it here, and so 8 divided by 8 it is. So k equals to 1. First we found k, right? So I hope you understood till here. So I'm erasing the board. So k is 1, put it here. And let's name this polynomial as px. Px equals to kx square plus 3. Substituting the value of k, will get it is, if you put k is equals to 1, then the polynomial is this. Now find the 0 of the polynomial. So when we find 0 of the polynomial, what do? We equate this to 0 and get the answer. So it can be factorize this. So this can be written as hmm. 2x plus x is 3x. 2 into, let's say 1. 2 into 1 is 2. So that's how I did the factorization. So at finding common, so this polynomial is, if you factorize the polynomial, it is x plus 2 into x plus 1. So how do you find the zeros? You equate it to 0 and you'll get two equations. Therefore, this is the final answer. Hence, the zeros of this polynomial is minus 2 and minus 4. Okay. The reason we are writing or, I hope you understand, you know by now that something into something goes to 0 means either this is 0 or this is 0. That's how it proceeded. But ultimately, we'll say that the zeros of this polynomial are minus 2 and minus 1. So if you put x equals to minus 2 and minus 1 here, not here, okay, here it is going to become 0. Okay, we have some more questions. So we have this question: if sum and product of zeros of this polynomial are equal, find k. Now look at this polynomial and first find a, b and c. A is your k, b is 2 and c is 3k. So this is according to question. Sum of zeros is equal to product of zeros, or equal to product of zeros. So sum of zeros formula is minus b by a, c by a. So it is so this k and this k will get cancelled. So if you send that k to the other side, it is, and bring 3 here, So this is your answer. So I hope you understood. As simple as this, sum of zeros equals to product of zeros. So sum of zeros formula is minus b by a. Product of zeros is c by a, and you just substitute the values of a and b, c, and you solve. You'll get this. So since we don't know the zeros here, those alpha and beta, but we know a, b, and c, and this is the sum of zeros and product of zeros. This is the relation that links zero and the coefficients of the quadratic polynomial. So it is how, this is how it's used here. Okay, now let's do another question. All right, we have this question. If alpha and beta are zeros of a polynomial x squared plus 6x plus 9, then form a polynomial whose zeros are minus alpha and minus beta. Also find alpha squared plus beta squared. So this I have added an extra layer to this question. Let us find this one also. Okay. First you will have to find zeros of this polynomial, and if alpha and beta are the zeros, minus alpha and minus beta will be another zeros for a different polynomial. Okay. So let's first find alpha and beta. So name this polynomial px. Now factorize. Now how to find the zero? We equate this to 0. I hope by now you know what is going on here. Okay, so first we are factorizing a quadratic polynomial. So we are factorizing by breaking the middle term. So 3x plus 3x is 6x, 3 into 3 is 9, right? So here x plus 3, and we'll have x plus 3, or I can say this x plus 3 whole square equals to 0. So if you put root on both sides, under root 0 is 0, under root this is square will be removed, so we'll get x equals to minus 3. So or you'll get the two values of x are from here only you'll get the two values of x are minus 3 and minus 3. Okay, if you solve this you'll get x equals to minus 3. If you solve this, if you say x plus 3 equals to 0, you'll get x equals to minus 3 only. Or this one also says the same thing, x plus 3 whole square equals to 0 means that x equals to minus 3 twice. Okay, so there are quadratic polynomials and quadratic equations where the zeros or the roots, two roots or two zeros are equal, are same. So this is a case where two zeros are equal. Okay, so when this happens, two zeros are equal, and the zeros are minus 3 and minus 3. So if alpha, let's say you got alpha is 3, so alpha is minus 3, your beta is also minus 3. So minus alpha is going to be what? It's going to be 3, and minus beta is going to be 3. If you multiply with minus sign. First we found the zeros of this polynomial. Now we are making another polynomial whose zeros are 3 and 3. Sorry, 3 comma 3. That's what they are saying. if alpha beta are zeros of a polynomial this, then form a polynomial whose zeros are minus alpha and minus beta. So you got minus alpha is 3 and minus beta is 3. So next polynomial is this, which I haven't discussed yet, that when you know zeros of a polynomial, zeros of a quadratic polynomial, then you can form the polynomial by this relation. The given polynomial is, remember this formula, x square minus sum of zeros into x plus product of zeros. So if you know the zeros of a polynomial, if you put the values here, you'll get the polynomial. So our polynomial is x square minus, what is the sum of zeros? Our zeros are 3 and 3. So it is x, product of zeros means 3 into 3 is 9. So it is x square minus 6x plus 9. Okay. So this is the given polynomial. Now, this one also you can check. Since our zeros are minus 3 and minus 3, what is their sum? It's going to be minus 6, but outside it will multiply with minus. It's going to be plus 6x plus 9. So plus 6x plus 9. Same formula, when you put the sum of zeros and product of zeros, you will get the polynomial. So this is the second question, the polynomial. Now third one, also find alpha square and beta square. This is as easy. The question says like how much is alpha square? Alpha is minus 3 square is 9. So minus 3 square is 9. So 9 plus 9 it is 18. This much. Alright, let's do another one. So here again we have a question which says a quadratic polynomial whose zeros are minus 3 and 4 is, so using the same formula, it's given by x square minus sum of zeros into x plus product of zeros will give us the polynomial. What are zeros? Minus 3 and 4. Sum of them means we'll have to add plus product of zeros. That means minus 3 into 4. So minus 3 plus 4 is 1 and we have minus. So minus 1x. Okay. So minus into plus is minus. 3 4s are 12. So ultimately like this is the polynomial. This is the quadratic polynomial whose zeros are minus 3 and 4. Alright, let's move on to another question. Let's focus on this question. Find a quadratic polynomial whose sum and product of zeros are minus 8 by 3 and 4 by 3 respectively. Also find the zeros of the polynomial. So we have x square minus sum of zeros is this. And product of zeros is 4 by 3. They have given this. So it is this is the polynomial. Now, Also find the zeros of the polynomial. You'll have to find the zeros of this polynomial, the values of x, which makes it 0. So whenever you see a polynomial, a quadratic polynomial whose coefficients are fractions, okay, in this case the coefficient of x square, x is a fraction and the constant term is a fraction. So if this kind of polynomial exists, if this kind of quadratic polynomial exists in your question, it may, even if one of the coefficient is 0, sorry, a fraction, this one is a fraction or this one is a fraction or this one is a fraction, the way to do is you find the LCM first. Okay, so LCM of this is 3, so this is nobody means 1, it's going to be 3x square plus 8x plus 4. Okay, so I'm writing it here, 1 by 3, 3x square plus 8x plus 4. Okay, so this 1 by 3 is going to stay till the end. So now we'll factorize this quadratic polynomial. So 3 4s are 12 and 6 into 2 is 12 and 6 plus 2 is 8. Okay, I'm going to erase this. This is a problem. Okay, means the space problem. So first common, so this is the polynomial. Okay, factorized form of the polynomial. Now how do you find the zeros? In order to find the 0, we'll equate this to 0. So equating it to 0 means till now let's say this is the polynomial px to this. Now to find the 0, we'll equate px to 0. That means equate this entire thing to 0. So 1 by 3, 3x plus 2. So 1 by 3 into this into this into this into this into this equals to 0. Obviously 1 by 3 is not 0. So either this is 0 or this is 0. So if you say 3x plus 2 equals to 0 and solve this, you'll get x equals to minus 2 by 3. I hope you can see it. It is x equals to minus 2 by 3. You send this 2 to the other side. And if this is 0, then x equals to minus 2. So the zeros are minus 2 by 3 and minus 2. The zeros of the polynomial so formed from this information. Okay, this was the polynomial, right? So zeros of this polynomial is minus 2 by 3 and minus 2. Right, so this was a good question. Let's move to another one. Okay, let's look at this question. Find the value of k if one of the zeros of the polynomial, number 1, this is the polynomial, is 1, this is the polynomial is 2, and for this given polynomial is 4. Means 1, 2 and 4 are one of the zeros of the given polynomials. Each polynomial has at least 1, or means each polynomial has at most 2 zeros, Or let's say in simple language, each polynomial has two zeros. So for each of them, 1 0 is given. For this one, 1 is a 0 of this polynomial. For this one, 2 is a 0 of this polynomial. And for this polynomial, 4 is a 0 of this polynomial. So you'll have to find the unknown k. So let me do question number 3. Let's solve this. For this one, if -4 is a 0 of a polynomial, although you have another 0 also, but here this is enough to solve the answer, to solve this question. Okay. If -4 is a 0 of this polynomial, then name this polynomial. Okay. Say px is this x square. So if -4 is a 0 of this polynomial, then it means when you put the value of x as -4, then this polynomial must become 0. Okay. If you put the value of x as -4, this polynomial becomes 0. That's what it means. So let's put the value of x as -4. So, so this becomes an equation, right? Equation in which k is the only unknown variable. So you can solve this linear equation, right? So -4 square is 16, minus minus plus. So this minus 2k minus 2. So 16 plus 4 is 20, 20 minus 2 is 18. So you, okay, 18 equals to 2k. I'm sending this 2k to the other side, and you divide by 2. So k is how much? So k is your 9. Value of k is 9. Similarly, solve this one. Okay, so it's easy. Solve these two. Hint is like this. If you name this polynomial fx, okay, then f of 1 must be 0. Means if you put the value of x as 1, it must be 0. It's going to be like this: 3 1 square plus k into 1 plus 4 equals to 0. Solve this, you'll get k. Similarly, here also, if you put x equals to 2, it is going to be, it is equal to 0. So you don't have to name also like fx or px. Simply substituting the value of x as these values and equating it to 0, you'll get the value of the unknown k. All right, let's move to another question. Okay, let us solve this question. It says, consider alpha comma beta are the zeros of the polynomial this 3x square minus 8x plus k. So the zeros of this polynomial are alpha and beta. Find the value of k if alpha square plus beta square equals to 40 by 9. Okay, let's work it out. Okay, compare this equation polynomial with the general form ax square plus bx plus c. So comparing, what will you get? A is 3, b is minus 8, and c is k. Right? Now, sum of zeros, alpha plus beta, is minus b by a. So that is minus of 8 upon 3. So alpha plus beta is 8 upon 3, and alpha into beta is C by A K by 3. Now we'll have to use this main hint given in the question, alpha square plus beta square. So do you know a relation between alpha square plus beta square and this and this? A very famous identity or a formula which you know is alpha plus beta square is alpha square plus beta square plus 2 alpha beta. A plus b whole square is a square plus b square plus 2ab. So this particular question is, you know, specially meant for students to remember this formula, okay, or to recall this formula. So you know alpha plus beta is this 8 by 3 whole square, and alpha square plus beta square they have given 40 by 9, and 2 times alpha beta. So alpha beta is k by 3, 2k by 3. So if we solve this equation, we will get the value of k. So let us solve it. This is 64 upon 9. Bring here 64 minus 40. 24 upon 9. This 3 will come here and 2 will go down. 3 1 3 1 3 3 3 is 24, 1 2 4 is 8. So k equals to 4. So I hope you understood the solution. Here the main thing was to know this a plus b whole square formula and how to use it. This is, consider this a square plus b square. So you find a plus b, that is alpha plus beta, and alpha into beta, the sum of the roots and product of the roots, and put it here and you'll get the answer. So let's do another one. All right, here we have the question. If alpha and beta are the zeros of this polynomial, this quadratic polynomial, then find the value of 1 by alpha plus 1 by beta. So there are two ways of solving this question. One is you find the zeros of the polynomial, which is easy. You solve this polynomial, means you factorize the polynomial and get the two zeros, and one zero is alpha, another is beta. You put it here in this expression and solve, you'll get the answer. Another way of solving this question is, okay, from the given polynomial, tell me what is A. A is 4, right? So B is 3 and C is 7. Now, okay, what is sum of sum of zeros is minus B by A, so minus 3 by 4, and product of zeros is C by A. Okay, now so this can be written as, if you take LCM, right? If you take LCM, this is the result. So beta plus alpha or alpha plus beta both mean same. So this is, you have minus 3 by 4 upon 7 by 4. So you have a fraction upon fraction. So this means the denominator always divides the numerator, right? So what do we do? You simplify this by, I don't have the space, that's why I'm writing it here. Okay, I'd rather do it here. So this one, minus 3 by 4 is being divided by 7 by 4. So next is division sign will change into multiplication and they will flip. Means after you change it, then there will be a reciprocal. Minus 3 by 7. This is your answer, right? So direct method would be, if you see this, write this as it is, just flip this one. So write this as it is, the numerator, to flip the denominator, you'll get the answer. Otherwise, why are we flipping? This is the reason. So so this is how it's done. Okay, this is a shortcut, let's say. Otherwise, you'll have to find the zeros of the polynomial and put the values of alpha and beta and solve them. That is also done. That will also work. If you find that one easy, then you can apply uh, that method and get the answer. Please try and see which one is the faster method and whether you get the same answer or not. All right. Okay, let us solve this question. A linear polynomial px equals to minus 9x upon 3. So minus 9x plus 3 is a linear polynomial because the degree of x is 1. Degree means the highest power of a variable in a polynomial. So the highest power is 1 means it is a linear polynomial. Has exactly 1 0. A linear polynomial this has exactly 1 0, which is out of these 4 options, one of them is correct. So remember, a linear polynomial has only 1 0 all the time. A quadratic has 2 zeros. Now look here. How do you find the answer? How do you find zeros of a polynomial? So I told you, to find the 0, we will simply equate this to 0. To find 0, we'll equate the polynomial to 0 and solve this equation. It becomes an equation. Now solve this equation. Solving this equation means keeping x alone. So minus minus gets cancelled. 3 1s are, 3 3s are. X equals to 1 by 3 is the zero of this linear polynomial. So, okay. So I hope you understood the solution. This is a very easy question. Now, as I have been telling you from the beginning, that 0 of a polynomial means if you put the value of x, this value, the polynomials must become 0. You may check. If x is 1 by 3, so minus 9 into, in place of x, put 1 by 3 plus 3. So 3 1s are, 3 3s are. So it is minus 3 plus 3. 3 into 1 is 3, right? 0. So if your x value is 1 by 3, the polynomial is becoming 0. So that's why this value is called the 0 of the polynomial. So we have this question. A real number c is called a 0 of the polynomial if out of these four options, one is the correct answer. If P of C is equal to 0. This means, imagine you have a polynomial Px. Means, for example, let's say, suppose, for this is just an example. Consider a quadratic polynomial made up of x. So we name as Px. Okay. So if a polynomial was made up of y, we would say Py or Fy. No problem. So consider this polynomial. So for that this quadratic polynomial has how many zeros? It has two zeros, right? So when those values of x, the zeros of x, if you substitute here, it becomes 0. Means the polynomial becomes 0, isn't it? Just like the previous one. In the previous question, it was like this: p of x equals to minus 9x plus 3. This was the given polynomial, and we found that x equals to 1 by 3 is the 0 of the given polynomial. So think that this is a real number. So if this real number is a 0 of the polynomial, then when we substitute this x value by the 0, by the real number, then after substituting what did we see? The polynomial became 0, isn't it? So that's what it means. So a real number c is called a 0 of the polynomial. Take this example that 1 by 3 is a 0 of this polynomial, right? Forget about this. Is a 0 of this polynomial. So when we substitute x value as this, so p of 1 by 3 becomes 0. That's how c is a 0 of the polynomial. So p of c must be 0. Okay. So I hope you understood. Now we are about to discuss something important from this chapter. So that is, this chapter dealt with zeros of a polynomial almost in every questions. But what does that mean, graphically? This particular, examples, the examples that I'm going to produce here is going to clarify what does zero of a polynomial mean. In fact, a very important statement, please note it down. It says that zero of a polynomial is precisely the x coordinate or abscissa. X coordinate is also called abscissa of the point where the graph of Px, means the polynomial, intersects x-axis. Zero of a polynomial is precisely the x coordinate of the point where the graph of Px intersects x-axis. Let's see. Find the number of zeros of Px in each case. Just remember that every polynomial can be plotted on a graph, and when you plot the polynomials on a graph, they will form curves like this. Okay. Some polynomials will be a straight line also, but consider these curves, and these are all polynomials. Okay, so let's say, where is the line, the curve intersecting the x-axis? So here it's intersecting at this point, right? So what is the coordinate of this point? For example, any point on the x-axis, y part is 0, right? And x part, you'll get some value from 0 to here. So this value, let's say it is 2 or 3, and since it's on the positive side of the x-axis, so you'll get some value. So let's say that value is a, for example. X part is a. So this is the 0 of this polynomial Px. Usually A polynomial is equated with y. If you say px equals to y, then what happens is for every x, polynomial is some, what, how a polynomial looks like, right? So the entire polynomial, if you equate it to y, what happens is for every x, you will get some value of y, right? So when you plot those points, the curve forms like this. The reason we are equating the polynomial to y is just to, uh, you know, bring that polynomial into picture, so that for every x, if you get y, let's say if your x is 1, after solving, let's say polynomial is, for example, 3x square plus x. Suppose. So if x is 1, then what is y? So 1 square is 1. So 3 plus 1, 4. Similarly, if x is 0, so this is 0, right? So that's how it works. So for every x, you are getting some y. So if you plot all these points and connect them, they will form curves like this. So this was an example to explain why we are equating polynomial to y. Okay, px equals to y. So that for each x, you get some y. So at this point, at this point where the curve touches the x-axis or intersects the x-axis, your y part is 0, means this is called the 0 of the polynomial. This point is called the 0 of the polynomial, because at this point your y is becoming 0. Y is becoming 0. So how many zeros does this polynomial has? So number of zeros is 1. How many zeros does this polynomial has? Where, look at the line where it intersects x-axis. 1, 2 and 3. So number of zeros is 3. So we have more number of graphs to help you understand the zeros of the polynomial through graph. So this kind of question you can see in your multiple choice section, where they'll give you 4 different graphs. From there, uh, you might have to answer the number of zeros. Okay. So let's consider one example. Let's say this is your x-axis and this is your y-axis origin. Okay. So how many zeros does this polynomial have? So 1, even if it touches x-axis, okay, it doesn't have to cross. That point is also considered 0. So this has 3. This polynomial has 3 zeros. So I hope you are understanding. So let's look at few more graphs. The fourth one. So at how many points on the x-axis the graph is intersecting or is touching? 1, 2, 3, 4. So these 4 points, the graph is crossing the x-axis. So that's why, so here number of zeros is 4. Don't consider this point, okay, where the graph intersects the y-axis. This is not the 0 of the polynomial. In this case, we have 2 zeros. One is this, another is this. So number of zeros is 2. In fact, this is the one we are extensively studying in this chapter, a quadratic polynomial. So a quadratic polynomial, graph of quadratic polynomial is always this shape, either U-shaped or let's say a valley or a hill or an umbrella you can call. Okay, so this is a graph of a quadratic second degree polynomial. Okay, and also one thing, this graph has a name. We call the name of this graph is parabola. It comes. This graph is formed by this equation ax square plus bx plus c by the polynomial this or equation, no problem. So this U-shaped graph, either in the upward direction or in the downward direction, uh, this graph is called parabola, and it comes from this equation, okay, or polynomial. If there is no zero, if there is no equal to sign, it's a polynomial. If there is an equal to sign, it's an equation, but both will make the same graph. So that's why you see here it's crossing, it's touching the x-axis at two parts, so it has two zeros. What about this? So this is a straight line. It's intersecting y-axis at this point, but is it intersecting x-axis at any point? No. So that's why this graph, this line, which we call graph only, this line does not have a zero. So number of zeros is 0. How many zeros are here? 0. It's not intersecting x-axis at any point. Suppose the line was this. Consider, let's say line, I'll write L only. The graph is this. How many zero does this line have? It's intersecting at one point, so it has 1 0. The line L or this graph has 1 0 because it's intersecting x-axis at one point. All right, so we'll do a little more about parabola. All right, let's look at these four different graphs of quadratic polynomial. Ax square plus bx plus c. Okay, this is a quadratic polynomial. We all are now much more familiar about. Okay, now this graph from this polynomial, you can see these kinds of graph. So here number of zeros, it's 2 because the graph is intersecting at 2 points. In fact, they say in this polynomial, if the coefficient of x square means the number in front of x square, if that is a positive number, if it is greater than 0, then you will see the parabola in U shape, okay, upward direction. While if this a, the first number in front of x square is a negative number, then this is the graph. It will be in the downward direction, or let's say the parabola will take the shape of an umbrella. Even here number of zeros is 2 because it is intersecting the x-axis at two places. Well, what about this? Here obviously a is greater than 0. This one is a positive number, that's why it's in the opposite direction, but it's touching x-axis only at one point. So we know that when we solve this quadratic polynomial or a quadratic equation, we always get two zeros or two roots. But how come it's intersecting at only one point? So that means here in this case number of zeros is 1. Yes, it is 1. Number of zeros is 1. It looks like this, number of zeros is 1, but when we solve, what happens is in this case the number of zeros, there are actually two number of zeros, but both are equal. You've seen those cases, in our examples where after solving we see that x is two values is 2 and 2, or x is let's say minus 1 by 3, another value is also minus 1 by 3. Okay, so this is a case when two zeros both are equal, then the graph touches the x-axis only at one point. Very important, this concept, the graphical and the algebraical form. What about this? It's not intersecting the x-axis at any point. It's in the downward direction or it may be in upward direction, but still it's not touching the x-axis. This happens when, uh, so here the graph is not touching the x-axis, means there is no real zero. Means the zero of the equation, the zero of this polynomial is not a real number. It is an imaginary number, which we will know when we study nature of roots of a quadratic equation. So in a quadratic equation or a quadratic polynomial, uh, what kind of roots or zeros will we get is derived by discriminant, that is b square minus 4ac. The same b, c and a, you put it here. If this value is less than 0, if discriminant comes less than 0 after substituting the values and doing the simplification, if it is a negative number, then your graph is this. It is not touching the x-axis. If discriminant is equal to 0, then the graph is touching exactly at one point. We say that the two roots are equal. Okay. If it is greater than 0, then it has two distinct roots or two distinct zeros, means two different zeros, like this and this, this and this. For these two cases, discriminant is bigger than 0, means a positive number. It is 0 for this one, and it is less than 0, means a negative number for this one. Okay, so if discriminant is less than 0, we say the roots are imaginary numbers, which you will learn in grade 11. In the chapter complex number, you will study about the real numbers and imaginary numbers. A real number, you know the definition of real number. It's a number that can be plotted on a number line. So you know a number line till minus infinity, we have infinity. In between it's 0 and negative numbers, and we have positive numbers. So any number that you can put here, whether it's rational, irrational, negative, positive, fraction, decimal, that number is a real number. So this is it. So I hope you understood the graph, the theory behind the graph, okay, the zeros of a polynomial. So here comes the end of our video, and as we close today's session, remember, success is the sum of small efforts repeated day in and day out. So trust the process and keep practicing. Please share your thoughts, feedback, or any mistakes you caught in the comments. And if this video helped you, hit like and subscribe. It motivates me. Till then, keep practicing. I'll see you in the next masterclass. Thank you.